All right. Good morning, everyone. I hope that you are all doing okay today. It's getting real cold in the morning these days, but I guess it's fall, so it is what it is. I'm just looking at this OBS, and I'm noticing that there's like 10,000 dropped frames already, and it's dropping to 0. The stream, I don't know what's going on with it. So forgive me in advance if you're watching this stream, and forgive me in advance if you're watching this later and YouTube has done a terrible job. I'm gonna hit the start recording button, and I'm hoping that this will also just make a file. So if the stream is terrible, I'll at least have a backup. Now it's all green. Can all of you, if you're here right now, let me know later if the stream is terrible, and I'll just replace it with a video version of it if I can. Okay, all right. So what I want us to do today is to continue off with what we were doing on Monday. I want to start thinking about testing, and to be really, really clear, just to make sure that we're clear about what expectations are for the different phases of the project. We are not doing testing in phase 2. This is phase 3 stuff that we're starting right now. So all of the phase 2 stuff ends at the validation of input. This is where we did like the very last thing of changing our logic layer to throw custom exceptions. That's the end of phase 2 stuff for us. What we're talking about today is focusing on phase 3 stuff in the course. So what I want you to be able to do by the end of today's lecture is I want you to be able to come up with some test data. So testing kind of has like this tiny little planning step that we have, or tiny little design step that we're going to have, where we effectively want to come up with the data that we're going to use for the purpose of testing. And this is going to drive us into starting to do some manual testing, which is something that we're all quite familiar with at this point. And then very quickly, we're going to discover that that's tedious. And so we'll try to automate this. We'll try to write some code that will do this for us, as opposed to having to do that. I do want to quickly remind you of what we finished off with last time, which is the goal of testing in general. The goal of testing for us for this course is that we want to verify that our software works under the conditions that our parents or the people who would actually be using our software would want to use it. Yeah. So phase 3 is going to focus on testing and persistence. Yeah, so there's not going to be much more logic stuff that we add to the stuff that we're doing in the course. I'm getting ahead of myself, but to answer your question, we're going to start talking about some other design philosophies that are related to adding another layer to the existing layered setup that we've got. But we're not really going to spend too much time thinking more about the logic layer stuff that we have right now. Yeah. So the goal of testing here is to verify that our software works given the inputs that real people would provide. So I really, really want to have confidence that when my parents start typing stuff into my code or into my program, that it behaves the way that I expected it to behave when I wrote it in the first place. I want to make sure that our scope is clear for what we're doing here. The things that we are going to have the responsibility of testing is the valid inputs. These are the happy path set of inputs that we're providing. This is what I'd expect for someone to actually enter as I give them instructions about what to enter. We're going to think about invalid inputs, and invalid here is for our domain. So this is a valid data, possibly, but it's invalid in the context of our domain. So I'm thinking about things like integers versus positive numbers. The things that we're not going to test in this course is UI classes. We're not going to try and automatically provide input for scanner. That's not what we're doing in this course. We are not going to do that at all. We're not going to test properly invalid inputs. This is kind of going back to design by contract, where we're checking to make sure, has null been passed to this? We're not testing null. We're testing what our parents can actually give us as input. Our parents cannot hit a null key on the keyboard. We are not going to write tests for null. Really generally, we do not want design by contract to show up here at all. For all the tests that we write, we should not get any design by contract failures. And the other thing that we're not going to be testing is, I put the word fuzzing here. This is a link to a Wikipedia article. You can read about this if you want, but this is outside of scope for this course. We're not making it out as though our parents are hackers. They're not trying to break our system by putting arbitrary binary data into our software. That's not something that we care about. Our parents don't know how to do reflection in Java and like set fields programmatically to be accessible and then change their values. That's not something that we care about in this course. We care about valid inputs and then invalid inputs. So correct types, but the values themselves might be invalid in the domain that we've got. We want to start by focusing on test data. We want to figure out what it is that we're going to test. We need to focus on what we want to test. And in the context of what we've got so far, that effectively means we want to focus on methods. These are the things that we really want to do testing of. The methods that we're thinking about for this are things like, in our validation or builder classes, each of the inputs that we're providing. And in our logic layer, we have a bunch of methods that we're going to define that will actually do the stuff that we have for our software. So we want to know what to test, and our focus is going to be on methods. We want to know what the inputs are going to be for that test. So this is going to be the data that we can type in. My parents are sitting down at a keyboard. What can they actually type in that is valid data, or again, invalid here within the context of our domain? They can type in a number. It's a negative number when I was expecting there to be a positive number. It might also be in the context of writing tests for our logic layer classes. This is data that is generated as a result of typing something in. So in our Pokemon example, we've got domain logic layer classes that are accepting instances of type Pokemon. My parents can't actually make a Pokemon, but I can make a Pokemon that's valid or invalid and pass it to this logic layer class for testing. The other thing that I want to figure out here is, what's the expected behavior given that input? So if I type something in that is valid, I'm expecting either a return value that corresponds to that is also valid, or I'm expecting some side effects in state to happen. If I provide something that's invalid, so big air quotes here again, invalid in the context of our domain, I'm expecting an exception to be thrown. I want that to happen. An exception being thrown here is a successful test if I'm passing something that is invalid to us here. The expected behavior are really the observations that I can make about the state of my software after having provided that input. So I want to focus on what to test. These are the methods that we're writing. I want to focus on what to provide as input. This is valid and invalid data in the context of our domain. And I want to know what I'm expecting to get back from that. What observations I'm able to make about the state of my software in the form of return values, side effects, or exceptions being thrown. In terms of inputs, there's two different kinds or two different classifications of inputs that I'm going to describe to you. One is general case inputs. So these are the things that I consider to be valid. This is what I expect my mom or my dad to type in when I'm asking for a nickname. They'll give something properly valid here, press the enter key, and I would expect things to just keep on moving along here. The other are edge case test inputs, edge case inputs. Edge case inputs are things that are valid for the type, but they may be invalid for the domain that I have. Very often, really often, in the kinds of data that we're looking at, in the kinds of classes that we're looking at, this is the empty thing. If I'm thinking about abstract data types and data structures, I've got a list, I've got a stack, I've got a queue, I've got other kinds of data structures. This is the empty list. This is the empty queue. This is the empty stack. It's valid for it to be empty, but it may not be valid in my domain. It's valid for it to be empty. It might be the place where I'm, for example, adding a first node into a list. I want to make sure that that actually works successfully. For us, in terms of the stuff that we're working on right now in class, the edge case for us is going to be the empty string. It's also going to be the data that kind of sits right alongside the valid and invalid boundary. So if we have negative numbers versus positive numbers that we're expecting, an edge case might be 0 or -1 or 1, right up to that edge of what is considered to be valid for the test data that we're working with. I would like to take a moment here to start creating some test data, and I want to create some test data for one of this builder classes that we've got, and I want to focus specifically on this nickname method here. I'm going to open up IntelliJ, and I've got it right beside my screen here. And the nickname method that we've got here is what we're using to provide a valid nickname to our Pokemon. What we've decided is that an invalid nickname in the context of this domain is something that is empty. A nickname must have at least one character in it. I want to make some test data for this, and so I'm going to open up an incredibly specialized and highly technical tool here. Spreadsheets. I want to make some test data. Yeah. Spreadsheets are actually super powerful. Oh gosh, digression time, small digression time. Spreadsheets are incredibly powerful. They drive a lot of stuff that goes on in business, and a lot of our jobs, when we get into jobs, is taking spreadsheets and turning them to software. Spreadsheets are infinitely flexible. They use a really cool thing. If you want to read about this, there's this idea of data flow. Data flow is like, as you make changes in one cell, it possibly affects many other cells, and it's a big problem. It's a big problem. Yes. No, I haven't. 16-bit processor in Excel, but I've seen people doing quite impressive stuff with software inside of Excel spreadsheets. Yeah. Oh, excuse me. Okay, so for this method, I want to come up with the test data that I want to test. The inputs to this method are of type string. So I'm going to come up with string input for this. The first test case that I want to come up with here is for the happy path. This is the thing that I would want my parents to do when they are prompted to enter a nickname. The string that I'm going to put here is Bulby. Great. I'm going to make Bulbasaur. I'm expecting them to put something in here that has the correct number of characters, a non-empty string. The expected behavior, the observation that I eventually want to make about this, is that eventually, so I can't make this observation right away because my builder doesn't have accessors. That's fine. I don't really want to test just an accessor. Eventually, I can get a valid Pokemon with Bulby as the nickname. That's where I can make the observation. I provide Bulby as an input to this method. When I call the build, eventually, once I provided all this input, I should be able to check to see, does the Pokemon that was constructed have this nickname? Another input that I'm going to provide here, this is valid, but it's approaching the edge of what we consider to be valid, the letter B. This is one single character. It's a string still. It's one single character, but eventually valid Pokemon with B as a nickname. The last input that I want to test with this test data is the empty string. This is a valid string. The empty string is a string. It is an instance of string. It has length or size 0, but it is a valid string. The observation or expected behavior that I'm expecting to see here is invalid Pokemon name exception is thrown. That is what I would expect to see as my observed behavior from this. But this is immediately upon trying to pass that value to this. I'm expecting that to happen right away. I have not put null in this table. We are not testing null. My parents cannot press a null key on the keyboard. I'm providing inputs here that are what I would expect somebody to actually be able to enter in my software. We're basically pretending to be our parents here and coming up with the kinds of things that they can enter. I am not going to put null in this table. That's not something that I want to test in the context of what we're doing here with nickname. Yeah.
So you then have to test like Pokemon builder.nickname with other methods as well if your expected final outcome is like the full Pokemon?
So the question is, do I have to test the nickname method here with other methods if I'm expecting to eventually get a Pokemon? And yes, the answer is yes. In this context, I kind of have to go through the process of building up an entire valid Pokemon to be able to see that I've done that, and that's okay. That's okay in this case. The one case where I don't have to do that is this one, where I'm getting that exception being thrown effectively immediately as soon as I pass that value to that. Yeah?
We're validating input. Do we have to worry about internationalization?
When you're validating input, do you have to worry about internationalization? I don't even know what the button presses are to do this, but if you put an EX on, excuse me, oh my gosh, if you put an EX on Egu into Pokemon here, do you have to worry about that? No. The short answer, in the context of this course, no. Perhaps in the wild when you get a job, yes, but in the context of this course, no. What we're going to see in a little bit is that the data that we're putting here is stuff that we're just going to hard code into the data test cases that we're writing. So if you wanted to test for internationalization, you could, I guess, but that's a little bit outside the scope of this course. Yeah. Any other questions? Does this look okay to everybody? Okay. All right, awesome. Okay, so I've made some test data here. Now, I would like you to make some test data for me. I want us to look at this max HP method. I'm going to hold this up for a couple seconds. I'm going to switch to my code so we can all see it together for a couple seconds. And then I will pop over to the Mentimeter itself to see what kinds of inputs that you're providing. If you want to have a copy of that spreadsheet, I know it's highly technical, but if you want to have a copy of it, I put it alongside the lecture notes for today's lecture. So that's up there. Without the data, you'll have to type the data in yourself. Okay, I'm going to pop over to my code. Here's max HP right here. I'm going to make this just a little bit bigger so we can focus on just that method. Okay. And now I'm going to switch over to Mentimeter. Okay, so the test data, the inputs and expected behavior. So we've got lots of people picking negative values. Awesome. We have 0. We've got 1. I like these ones best because I am asking for both the input and the expected behavior. So invalid max HP is thrown. Invalid max HP is thrown for both -1 and 0. 100,000, 90, 67, 100. These are good, and I would expect these to be the happy path test cases. I'm going to be able to make a Pokemon that has 100,000 for HP is absurd, but yes, that's fine. That's okay in the context of the thing that we're building. This value, this is a very good thing to think about here. The string 100. I like that you've thought about this. But I'm going to say that this is not valid data. This is invalid, not double quotes invalid, but just invalid data. The max HP method takes an integer. I can't pass a string. And so it's not really reasonable for me to pass a string to this as a test case. My scanner takes a string and converts it to a number. Yes, I agree with you, but we're not testing scanner input here. We're just testing that one single method. It already gets an integer. We assume that that integer has been constructed for us. I like this one. This is going to be starting to test to see if we have overflow. I'll get to in just a second. This is testing to see if we have overflow. What I believe would happen, and gosh, I don't think I want to test this, but what I believe would happen with this is that this would overflow to become a very, very small negative number, like really, really small negative number. And so it effectively becomes a negative number here. Negative number, invalid HP exception, great. So these are all excellent, thank you. Yes, question back there. That's a great question. So the question is, what would happen if we passed a number to this that is effectively going to be something like a double, so a floating point number that has a decimal point, or something that really fits into long, so it's much bigger than the possible range of integer. In the case that we have with the code that we've got, and I'm going to go back to the code here, we are accepting type integer. And so we wouldn't even be able to compile the code if we tried to pass something that is a floating point number, and we wouldn't even be able to compile the code if we were to pass something that doesn't fit into integer like a long value. If I'm typing something into scanner, and again, we're not testing scanner here. So I like what you're thinking about, but we're not testing scanner. If I typed in a floating point number into scanner, that's outside the scope of what we're testing here. We're just assuming that at the point of this method, we already have a valid integer. That would be input validation, but again, it's the responsibility of scanner to do this for us at this point. Yeah. Okay, awesome. So I'm going to transcribe some of these into my spreadsheet here. What we've got are things like positive numbers. So I'm going to go up here and I'm going to say 1. And I would expect to make a Pokemon with max HP 1. I've got 0. I expect invalid max HP is thrown. I've got -1, and I expect invalid max HP is thrown. And I've got some other values here like 67. Is that the 6-7 thing? Yes. Yeah. Okay. My partner is a middle school teacher, so she teaches grade 7. My children are in elementary school. That has gone down very fast. Like, little kids know about this already in what would normally take a long time for it to show up in elementary school. But yeah, my kids know about 6-7 already. But I don't really know. I'm too old to know about this stuff now. So yeah, 6-7 Pokemon with max HP is 6-7 is created eventually. Okay, so I'm going to save this. I'm not going to update this spreadsheet on the course webpage. I assume that you can type this stuff in on your own, but I do want to transcribe this for the purpose of what we're doing here. So thank you all for sharing these inputs and outputs here. Now that we've got this data, we got to test it. We actually have to go through the process of taking this data and making observations about the inputs that we've been providing. And so the strategy that we have at our hands right now is I'm going to do this manually. I'm going to start this program. I'm going to type that stuff in, the test case that I'm looking at right now. I'm going to see if the behavior is what I expected it to be. Do I make the observation that I expected to see? And I just keep going back to 1 until all my data is tested. And so that would basically mean that I'm going over here and I'm going to go to interactive create Pokemon main. I'm going to run this main method. I'm going to enter the invalid string. Okay, great, it worked. The empty string failed. I got something from my perspective that looks like it has failed. It's forced me to type something in. I'll type in the letter B. Okay, now I have to do max HP, and this is to your question. I've made a valid Pokemon. I'm going to enter a nickname. It's still going to have 1 letter in it. Bulby -1 here. Sure, it's got to be a positive number. 100,067. Okay, great, awesome. And in this course, I'm sure you felt this way after a little while up to this point. Tedious to have to do this. It's error prone. If you have 50 test kill time that you want to verify, that the change that you've just made actually works the way that you expected it to. Surprise, computers are great at doing tedious stuff. That is lucky for us, we know how to program, so we can just write code to do this for us instead of doing it by hand every single time we want to do this. We are going to write software that is a test harness. Test harness is a piece of code that just runs all of our tests. We're going to write all these tests out, and we're going to tests for us. This code has some responsibilities. It has the responsibility of keeping track of successes, observe the expected behavior. Did this throw the exception I was expecting it to throw? Did I make the observation that this Pokemon has the correct nickname after it's been constructed? It also needs to track the number of exception when I was expecting it to be thrown. Was I able to make a Pokemon with an invalid nickname? And then ultimately it provides a report of what we've got at the end. Just like creating test data required a bunch of thing for this test harness, we need methods. Okay, awesome, we did that already. We need conditional statements. Yes, we've done conditional statements lots and lots of times. We need things that we can count with. All right, we can make some integer variables. And finally, we maybe need try and catch. Notice that I don't necessarily need loops to accomplish the. I would like to start right. I want to show you some code that I'm going to say this right now and I'll repeat it a couple times. The code that I'm going to show you, you are very welcome to just copy and paste into your own code structure. You don't need to write this. This is tedious to write. You don't need to rewrite it. It's so simple that you'd all converge on the same thing. You are very welcome to take this code that I'm going to show you. I'm going to switch over here to IntelliJ. I'm going to stop what I've got right now, and I'm going to open up to the sides. The code that we're looking at right now is up on the course webpage, up on the Git repository already in a separate branch that's called Test Harness. I've linked directly to this on the course webpage if you want to see on your own screen what we're doing right now. The very first thing I want to take a look at our application code goes. This is where it belongs. This is what we've primarily focused on for the purposes of this course. But there's this other folder that got created when we created our project in the first place, and that folder, beneath this, there is also a Java folder. And what I have started to do beneath this is to recreate some of the package structure that I have, and I've started to make some classes in this folder. I'm putting all of the things that I do not want to have any test stuff in my main folder. I don't want to put test stuff there at all. I want to keep them separated from each other. I don't want my test code to show up in my application code at all. The thing I want to file here, this is called Pokemon Test Harness. This on Test Harness. This, again, highly technical, very complicated, has some methods. It's got some print statements. It has some counters. We're eventually going to do try catch in the thing that we're doing right now in this file to be able to accomplish that. For each of the things that I want to test, I'm going to write a method. So the very first thing I'm going to do is test the invalid data. These are the things that I'm expecting to cause exceptions to be thrown. These are the things that I would expect to positively see, yes, I have successfully received an exception for this invalid data that I've got. I'm going to write a method. That method is going to be public static void. I don't really want to return anything from this. This is just going to be a method that does something. Okay. Actually pick something up and leave, or just like wander in and leave? Awesome. Test invalid nickname. It doesn't throw any exceptions. I want to test invalid nickname. I'm not going to test anything else in this do. I want to make sure that the test that I'm writing focuses really on just one thing as much as I can. I'm going to have to write tests that call all these methods in the happy path, but when I'm doing invalid stuff, I just want to do this one thing. I don't want to do lots and lots of stuff in this. I want to test invalid nickname. To test this invalid nickname, I need to make an instance of that builder. Pokemon builder. Builder is equal to new Pokemon builder. I'm going to have to do try catch. That method throws an exception. I'm hard coding in the empty string here. I'm not doing anything fancy. I'm not trying to load this from a file. I'm not trying to read the Excel file that I've got. I'm just hard coding it. I'm going to catch invalid nickname exception specifically. I've got this convenience method that I've written in advance of class here that's called pass. It increases the total number of successes, and it prints out in green a message that says, this test was successful. If I catch this specific exception, pass. I'm going to say successfully rejected empty string. I'm going to write another catch here. The other catch is going to be for all other types of exceptions. So when we were starting to write these custom exceptions, we didn't want to catch all exceptions. We wanted to catch those specific ones so we could print out an appropriate message for that specific behavior. For this test, my expected observation is that this specific exception is thrown. I would consider this to be a success. If any other kind of exception is thrown, null pointer exception, invalid index exception, invalid max HP exception, anything else, I consider that to be a failure. And so I have this convenience fail method that's just beneath pass that does the same thing. It increases the total number of failures. It prints this message out in red. Fail. Some parents are ever going to run. I'm going to do e.print stack trace. I want to see what that exception was. Exception was when I see that there's a failure, and then go back to my code and try and figure out why that's the state so I can see what's going in this exception. The other place that I want there to be a failure, and this is in the exceptional case here, I'll get to you in just a second, the other right here, should not have succeeded in setting empty string as nickname. If I get to line 36 here, I have failed this test that I want to make. I should never have been able to get to this point. An exception should have been raised before I got to this point, and I should get to that catch part. I'm still going to come back to you in just a second. The very last thing that I want to do here, and this is going to be kind of dumb looking, I got to call this method. I actually have to call this method in main. And now that I've called this method, my test harness, I'm going to run it. We'll try to run that method. Pass, I've successfully rejected this invalid input. And then my result at the bottom here is that I have one total test that was run. I have one test success. All of the tests pass. This is what I would hope to have as a result of this. Yeah.
To the stack trace, is that just for our own debugging, or should that be like, should should we remove that when we're handing it in, or is that something?
In a test, you are very responsibility. If we're thinking about design philosophies, it is the responsibility of a test to show the person writing the code. That's a very valid thing to want to do. Yes. Yeah.
When heading in phase 2, since we're already checking for because other TAs will try and break our code with invalid inputs, should we get nothing to break something?
If you want to, you're welcome to not to. Yeah. Of automated test suites. Yeah. Yeah. Okay. So this is our invalid. Pattern's going to look the same everywhere you want to write this. Copy and paste is your friend here. Duplicated code is not a problem in a test. I don't care that this pattern looks exactly the same for every test. I don't care that this pattern looks exactly the same for every single invalid case that you've got. If you want to get fancy and try and write code that is general, I welcome you to do it, but I'm not looking for great code here. I'm looking for something that tests the expected inputs and the expected outputs and the observations that you're making. The other case that I do want to test here is what I would consider to be the happy path. And so I'm going to make this one public static void test create. And so I'm going to make this one public static void test create Pokemon. Comment here that is, this is my happy path. I want to provide valid data. I'm expecting to get a Pokemon out at the end that I can make observations about the same data that I put into it. So I'm going to make a new instance of Builder here. I'm going to set exceptions in the happy path. I don't expect there to be any exception in my happy path case. I have failed. I want to print out a stack trace here. Again, I want to know what has caused that thing to fail. Simply saying things like builder dot nickname Bulby dot max HP